Hey Algebra 2, here we are for another video. In this video, we're going to talk about something called composition of functions. If you feel like we've been working on functions forever, it's because we have, but that's fine. We are almost out of this unit. We have this topic and then one more topic when we get back from break, and then we'll wrap up functions and move on. We're not going to move on from functions, we're just going to get more specific in the functions that we spend time talking about. So after this, we're going to spend some time on specific functions like quadratics and other types of functions like that. Anyway, as usual, fill out the notes while you watch this video, submit your notes. If you're typing them, please use the equation editor. It just looks that much nicer. I encourage you to pause the video and try the problems on your own first and then watch my explanation and see what happens. I have set up the video so that the Edpuzzle is actually going to pause at certain points and ask you to answer questions as well. So right off the bat here with these first 9 problems, I encourage you to pause the video and try them out and then press play and see if we get the same thing. If we do, awesome. If you don't, then make sure you're copying down the right answer and trying to understand why you might have got it wrong. But so go ahead, hit pause, and take it away. So in number 1, I have my function here, right? They give me my function f of x equals 4x minus 7. Remember, the x value is the input, and then f of whatever x is the output. Right? A function is just an equation, typically in 2 variables. So in this first one, it says find f of 3. So f of 3 means that x equals 3. So I'm going to sub 3 in 4x. So I'm going to have 4 times 3 minus 7. That's 12 minus 7. That's 5. So f of 3 is 5. And that means when x is 3, y is 5, or the output is 5, right? And if I were to graph this, it'd be the point 3, comma 5. And I'm going to do the same thing for all of these. So now I'm going to sub x equals negative 4 into my equation. So I'm going to have 4 times negative 4 minus 7. That's negative 16 minus 7, which is negative 23. So f of negative 4 equals negative 23. Right, so that would be when x, or when the input, you can say when x is negative 4, the output, or the y, is negative 23, right? And as a point, this is negative 4, negative 23. I can put anything in for x. I don't have to put a number. Obviously, a number makes the most sense, but I can put anything, right? If I ask you for f of BHS, then this just means I'm going to put BHS in for x. So sub BHS in place of x. So instead of 4x, I'm going to have 4 times BHS minus 7. I can't simplify this because I don't know what the heck 4 times BHS is, but the whole point here is just to get you comfortable with subbing anything in for x. Right, so that's just my answer, 4 times BHS minus 7. I'm going to keep going here. So here they give me a star. So now I'm going to sub star in for x. So instead of 4x minus 7, I'm going to have 4 times star minus 7. Right, because instead of there being an x here, there's a star. Right, so that's where I'm replacing the x with. Here they give me f of a. So I'm going to sub a in for x. I'm going to replace x with an a. So I'm going to have 4a minus 7 instead of 4x minus 7. Here they're asking me to sub in pizza. So I'm going to have 4 times pizza minus 7. I wish I had some pizza right now. It is 7:30 at night while I'm recording this video, and I have not eaten dinner. Anyway, so 4 times pizza minus 7, right? I just took whatever was in my parentheses and subbed, right? Replace x with that thing. In this case, it happened to be pizza. Number 7. So now I want to sub 2x for 7. 2x for x, right? So instead of x, we're going to replace it with 2x. So I'm going to have 4, and then instead of x, I'm going to have 2x, and then my minus 7 doesn't change. Anytime you substitute, you should use parentheses, so I should have parentheses here, right? Anytime I substitute a number, a symbol, a word, anything, I should use parentheses. And now I can simplify. 4 times 2x is 8x minus 7, right? So f of 2x is 8x minus 7. I can do the same thing here. I'm going to replace x with m plus 1. So 4 times m plus 1 minus 7. I'm going to simplify, so I'm going to distribute. So that'll be 4m plus 4 minus 7. Combine like terms. That's 4m minus 3. So f of m plus 1 became 4m minus 3. And then here I'm going to sub in a quadratic. I'm going to replace x with x squared minus 2. So I'm going to have 4 times x squared minus 2 in parentheses minus 7. Notice from my original, the only thing that is changing is this x, right? Instead of the x, I'm putting everything in replacement of that. For every single one of these, instead of the x, I put what was ever in its place. Didn't matter if it was a word, or a single letter, or a string of letters, or another expression, right? I'm just taking whatever was in the parentheses and replacing my x with it. And then I'm simplifying if I can. So this would be 4x squared minus 8 minus 7. Combine those like terms. 4x squared minus 15. So f of x squared minus 2 is 4x squared minus 15. And again, the whole point here is to show you that I can replace x, or my variable, whatever it happens to be, it's typically x, but I can replace my variable with anything that I want. Anything I put inside those parentheses, I can replace my variable with. Right? I can even do f of smiley face. I can take an emoji. Let's see. Well, let me type an emoji here. Let's see. So, yes, it will. So, I don't know. Let's see. We can do f of a bee, right? So, f of a bumblebee would equal 4 times a bumblebee minus 7. I can put absolutely anything in place of that x. Where we're really going to focus this video on, and I know I've been talking already for a long time and you're probably like, oh my god, Rusiki, we get it. Hopefully you do get it. And if you don't, please come to extra help or ask questions during class. But we're going to focus on things like 7, 8, and 9. And that's going to be the main focus of this video. 1 through 6 you should be pretty comfortable with, but 7, 8, and 9, that actually has a name for it. Notice how when we started, we had f of x equals 4x minus 7, and then by the time we finished those, we had a totally new function. That's not a coincidence. So, throughout this unit, we've been talking about how to make new functions out of existing ones. For example, we can transform a function by stretching it, shrinking it, shifting it up, down, left, or right, reflecting it to make a new one, right? That we did transformations of functions. We did them for a while. We can also add, subtract, multiply, and divide functions to make new ones. That's what we talked about in the last video, right? We talked about operations with functions. In this video, so now, we are going to talk about something called composition of functions. Well, what is composition of functions? composition of functions is when we combine two or more, typically just two, but two or more functions to create a new one. We do this by substituting one function or one equation into the other. And like I said, we did that already in problems 7, 8, and 9 on the first page. I didn't tell you that we had two functions. I just said find f of 2x, and you did it. Well, 2x is a function, right? It's a linear function. It's a line. So I put that inside the existing one, and I got a new one. So there is proper notation for this, and it might confuse you. It might seem a little bit funny, but you just have to practice it to get used to it. So this says, given the functions f and g, the composition of f with g, order matters here. So f with g looks like our new function will be h of x, and we write f parenthesis g parenthesis x parenthesis, close parenthesis. Or you can see it as f little circle g x. And we read this as, both of these are read as f of g of x. Right, so we read this as f of g of x. This does not mean multiply. Do not multiply f times g. We talked about multiplication. That was in the last video. This does not mean multiply. What this means is this means sub g of x into f of x. So basically, you're going to replace x from f of x with whatever g of x is. And like I said, we did this on the last page. It just has notation that can kind of make it complicated. So I can go the other way, right? I can compose g with f, and I can create a new function. We'll call that one k. And I would say this is g of f of x, right? Or g of f of x. This second notation here that I'm writing with the little circle, some people say fog and golf. This is typically seen on the SATs, which is why I'm showing it to you. So just, you should be familiar with both notations. If you don't like this one, just change it to the other one when you see it. That would be my advice. Right, so then we read this as g of f of x, and this means sub f of x into g of x. Sorry about that. Right, so I'm going to replace x from g of x with whatever f of x is. So it's just the opposite of the one above it. Order matters, so you work inside out, right? So it says when we do these problems, we work inside out. Start with the inside and work your way out. Alrighty, let's do some examples of composition of function then. So I can take whatever is inside my function and put it inside the other one, right? Whatever's inside my parentheses goes in place of x in the other function. So here I have f of g of 2. So that means instead of x in f of x, I'm going to have g of 2 in place of it, right? So I replace the x with the g of 2. And now to simplify this, I need to find out what g of 2 is. So g of 2 is going to be 2 times 2 plus 4, because g of x was 2x plus 4. So that's 4 plus 4, which is 8. So g of 2 was 8, and then I want to subtract 5, and I get 3. So f of g of 2 ended up being 3. In this one, I'm going to start inside out, so I'm going to take f of negative 1. I'm going to rewrite my functions over here just so I have them at quicker disposal. Right, so I'm going to take f of 1 and I'm going to put it in place for the x in g, right? We're working inside out, so start with the inside, go to the outside function. So this is going to become 2 times f of negative 1 plus 4. In order to simplify this, I need to figure out what f of negative 1 is. That's going to be negative 1 minus 5, negative 6. So this is going to become 2 times negative 6 plus 4. It's negative 12 plus 4, which is negative 8. So g of f of negative 1 came out to be negative 8. And that's just doing it with some values so you can get used to the notation and the process of working inside out. Now let's actually do it with the actual functions. So again, I'm going to rewrite my functions. I'm going to have f of x is x minus 5, and g of x is 2x plus 4. So for this example here, it says f of g of x, which means take g of x and put it in place of x in the f function. So remember, whatever's in my parentheses, right, I could have f of smiley face, and I would then do smiley face minus 5. So in this case, I'm going to do g of x minus 5. Then I need to know what g of x is. Well, g of x is x plus 4. So this has become, that's not a good sentence, this is going to become 2x plus 4, because that's what g of x was. And then I'm going to bring down my minus 5. Combine like terms to simplify. So this becomes 2x minus 1. So the new function that we've created by composing g of f of x, or sorry, f of g of x is 2x minus 1. Here is that funny notation. So some people read this as goff. It is actually g of f of x. Okay, and I'm going to copy my functions down again. So I've got f of x was x minus 5, and g of x, not a good space to write them. I don't have room there. Sorry guys, I want to make sure this is nice and neat for you. So my f of x was x minus 5, and my g of x equals 2x plus 4. So here I'm going to take f, what my function f is, and put it in place of g. So I'm going to have 2 times f of x plus 4. Now I know f of x is x minus 5. Then I'm going to bring down my plus 4. Distribute. Bring down my plus 4. Simplify by combining like terms. and I get 2x minus 6. So g of f of x was equal to 2x minus 6. I created a new function by putting f inside of g. They can also ask me to find some values. Oh, also, I just want to reinforce, this is not multiplication. Please know the difference between the notation, right? Multiplying f times g would just be like f of x, g of x, right? Notice the difference in that notation, please. So this is not multiplication. So here again, I'm going to work inside out. I'm still using the same f and g. So f of x is still x minus 5, and g of x is still 2x plus 4. So here, they want me to kind of set up an equation because it's telling me that it equals 24. So g of p is going to go into f of x. So f of g of p is equal to g of p minus 5. I can't simplify that until I know what g of p is. G of p means put p into the g equation. So it's going to be 2p plus 4. So this is 2p plus 4 minus 5, and it wanted this equal to 24. So now that I know what f of g of p is, I can set that equal to 24. So I'm going to have 2p plus 4 minus 5, because that was f of g of p, that's what I composed, equals 24. And now I can solve for p. So p is 25 halves. We have a few more examples. Remember, I can replace x with anything, smiley face, a function, a number, it does not matter. I just have to be careful about the order I do it in, watch my parentheses, and when I'm simplifying, make sure I'm following PEMDAS and all those good things. So a few more examples here. I'm going to use two new functions this time. This time, f of x is 2x squared. And g of x is 3x minus 1. And here they're telling me to put f inside of g. So I'm going to have 3 times f of x minus 1. Well, what is f of x? F of x is 2x squared minus 1. That's going to be 6x squared minus 1. Cannot be simplified any further, so g of f of x became 6x squared minus 1. Remember, order matters. So here, this funny notation, fog, if you will, we can change this to f of g of x. So this means I'm going to take g and put it into f. Recall our functions. F of x is 2x squared, and g of x is 3x minus 1. So I'm going to end up with f of g of x is equal to 2 times g of x squared, right? It means I'm replacing the x with g of x. Well, what is g of x? G of x is 3x minus 1. PEMDAS is very important here. Parentheses, exponents, multiplication, division, addition, subtraction, right? I need to do, this says 2 times, so that's multiplication, so I need to do my exponents first. 3x minus 1 squared does not mean distribute the squared. It means multiply by itself, right? Squared means multiply by itself. So I'm going to distribute this out. This becomes 9x squared, which then and then I get minus 3x, and then I get another minus 3x, and then I get a plus 1. So now this has become 2 times 9x squared minus 6x plus 1 if I simplify this. And I'm going to distribute that too. So I get 18x squared minus 12x plus 2. So f of g of x here became 18x squared minus 12x plus 2. Created a whole new function. All right, so this is our last little bit here for composition of functions. We can do compositions also with different representations, so graphs, tables, equations, the same way that we did operations. So I'm going to start here, and this is saying find f of g of 6. G of 6, I think it's actually easier in this case to find out what g of 6 is first. So this means go to the table, go to the graph, because the graph is g. So go to x equals 6 on the graph and find the output, or find the y. So I'm going to do that. So I'm going to go to 6, and I'm going to follow it up to this point here, which is the point 6, 3. So g of 6 is 3. So what I'm going to do is I'm going to take that value. This is going to become f of 3, because g of 6 was 3. And now I can sub that into my f function. So it's going to be 3 squared plus 4. 3 squared is 9. 9 plus 4, 13. Right, so f of g of 6 became 13. G of h of 2, work inside out. H of 2 means go to the table, because the table is labeled h of x. So go to the table and find the y value for x equals 2. So I'm going to go to my table. Here's x equals 2. What's the y? It's 13. So h of 2 is 13. So this is going to become g of 13, right? Because h of 2 was 13. Now this says go to my graph, go to 13 on the x, follow it up. So this point here, this is the point 13, 4. So g of 13 is 4. So g of h of 2 became 4. Last but not least, I have h of g of x, but I have h of g of 1 actually. It worked inside out. So what is g of 1? So go to your graph, go up to the point, this is the point 1, 2, so g of 1 is 2. So this will become h of 2, and then h of 2, as we saw from the last problem, was 13. So h of g of 1 got us 13. And that's composition of functions. I know that was a lot. I'm sorry this video was kind of long, but I think it was better than me giving you all this information on Zoom. So if you have questions, hopefully you were writing them down as you were watching the video, but if you have questions even after the video, make sure you jot them down so you can either ask them in class or send them to me in the email, email, and I will, an email, English is hard, and I will try my best to get back to you before class starts. We will do practice of this in class, next class, so please come prepared with your notes, ready to do practice.